Okay, so that's a good question, right? What is the lab about? What do you guys have to do? So here is what the lab is. The goal of Maple is to help you to see calculus from a graphing perspective. It reinforces what we learn in the actual classroom, what we are doing here today. You can go on Maple and because some of the graphs are very complicated. So since this is calculus 1, the first 2 weeks of class, you will learn the commands of Maple. And Professor Ali, who is your lab assistant, he posted a book that was wrote by me about 20 years ago, right? So the version of that book is old, but the commands doesn't really change, okay? So what I advise everyone to do is take that book, open Maple, and retype line by line to see how it's working. So that's what you guys should have been doing for the first 2 weeks of classes.
Yeah.
And the end, I think it was on page 16 of that book, there is called a lab activity number 1. You should try to answer those questions in the lab activity number 1.
Gotcha.
When the professor or when the assistant think you are ready, myself and him or I will create what is called a lab for you. A lab consists of a series of questions that you will have to answer using Maple. Okay, during the semester, you will have about 3 labs to do. And those labs are worth a certain percentage of your grade, which you can find on the syllabus. Now, if Maple is not working for you on your computer, I don't have a solution for the Chromebooks, but I think on the Mac they will. And I have to find out exactly how many people is not working. You, only you, will write out those commands by hand. You will email it to your professor. Your professor will then have to take time and type it into Maple to make sure if it's working. If it's not working, he'll send it back to you and say, hey, this is not working, fix it. In addition, only the people who Maple is not working on a computer will have to take a final exam for Maple. So you will have 2 final exams to take. Okay. So it's a little bit more work for everyone where Maple is not working on their computer. Does that answer your question, sir?
Yes, sir.
Okay. In today's topic, we'll be looking at the chain rule. Okay. The chain rule. So in the prior sections, we looked at derivatives and some of the rules of derivative. Okay. We looked at the power rule. We looked at the quotient rule and so forth. So today we want to look at chain rule. Okay. So it's a very powerful rule, the chain rule, and it really deals with a 2-step process, really. Okay. So, for example, if you recall, if I give you f of x is equal to x squared plus 2x, and I ask you to find f prime of x, or also known as dy dx, okay, has the same meaning. So we can say f prime of x is equal to, take the power from the top, 2x, and always subtract 1, so that becomes a 1 power. keep in mind there is a 1 here. So this becomes plus 1 times 2x to the 1 minus 1. Maybe I should write out all the steps for you. 2 times x to the 2 minus 1. When we're doing derivative, we always subtract 1 from the power. And now we simplify. Okay, so this becomes f prime of x is equal to 2x to the first power plus 2 times x to the 0 power. And if we simplify again, x to the 0 we know is 1. So we end up with 2x plus 2, right? Recall, anything to the 0 power is equal to 1. So 2 times 1 is 2. So this is f prime of x. Okay. Now, today, we will see a different rule. Okay. So for example, if I tell you f of x is equal to the square root of x squared plus 1. Now keep in mind that derivatives involve power, right? Derivative always works with power. Okay. So what do I mean by that? It is highly recommended that when you're given something that's not written in some power form, to rewrite it as f of x is equal to x squared plus 1 raised to the 1/2 power. Okay? X squared plus 1 raised to the 1/2 power. Right? Because square root has the same idea as 1/2 power. Okay? And now we can find, so now find the derivative or dy dx. Okay? So we can say dy dx is equal to, now be careful, the power here is 1/2, so it becomes 1/2 x squared plus 1. And remember, we always subtract 1, right? So here's a hint. Here's a hint for you. Anytime you have a power as a fraction, for fraction powers, subtract 1 implies the denominator. The denominator divided by itself. So instead of writing 1, you will write 2 over 2. Right? Take the denominator and divide it by itself. Okay? So realistically, what we should write here is dy dx, and this is to be continued. Dy dx is equal to 1/2 x squared plus 1 1/2 minus 2 over 2. But we're not finished. This is where the chain rule comes in now. This is the chain rule. Pay attention. Chain rule, we have to multiply this by the derivative of the inside, because we didn't touch the inside. So the derivative of the inside is 2x2 minus 1 plus, and remember the derivative of any constant is 0. This here is the chain rule. Okay. So the chain rule is sort of like a link. That's why we call it the chain rule, link. Okay. So you're not only taking the derivative of the product, you have to take the derivative of the inside here. Now we simplify. So we have dy dx is equal to 1/2 x squared plus 1 to the negative 1/2 power.
I have a question.
1 second.
Yes.
2x. Yes, questions?
Yes. For the chain rule, is it always multiplication when you're doing a chain rule, or could it also be addition and subtraction?
No. It's always multiplication.
Always. Okay, good. Thank you.
It always times the derivative of what I call the inside. This I refer to as the inside here.
Mhm.
Okay. This portion here is what we call the inside.
Okay.
Now this can be even simplified even further. Okay. So keep in mind this here means 1 over, so this becomes 1 over 2, the square root of x squared plus 1 times 2x. Okay. And then I can even simplify one more step or two more steps, step by step. And then this 2 can cancel with that 2. So we actually have x over the square root of x squared plus 1. So this would be dy dx. Yeah?
Yes.
So all of this is simplification.
Professor,
Yes, sir.
what happened to the half that was in front?
Are you referring to this half here?
Yeah.
So that half becomes over here 1 over 2.
Okay.
You have to keep in mind, right, that this portion here, this, let me don't do that in green. Let's do it in brown. This here really means 1 over x squared plus 1 to the positive 1/2. And then 1/2 power means square root. Yeah. A lot of algebra hidden here.
Meaning that's that 1/2 power to the right of the thing you just boxed in?
Yes. Negative power means fraction is 1 over what we have, right?
Okay.
Yes.
You have to recall powers, right? Power x to the minus n means 1 over x to the n.
Mm-hmm.
Okay. Yeah. Any questions on that? So this is really what the chain rule is, right? So there's a theorem, which I'll add now. This is just showing you what's happening with the theorem, the chain rule theorem. Okay. You don't have to use it because you will see that after you do a few practice, that this just becomes sort of like normal to write things out. Now, if I do this, I cannot write g of x, right? We cannot write g of x because the function will be u to the 5th. So we cannot write g of x. We have to write g of u is equal to u to the 5th. Do you agree with that? Okay. So here, what we do now, we're going to take the derivative of y with respect to u. Okay? Because this here is the same as if we write y is equal to u to the fifth. So dy du times now, okay? But remember, u is equal to 3x plus 2. So then we have to do du with respect to x. Okay, and that's where we're getting this from. With all of that being said, this is just to show you how we got this here. Where is that coming from? Okay. So many times people overlook this, but this is what's happening in the background. Okay. We overlook this by we saying, okay, why not just let g of x equal to 3x plus 2 to the fifth? Let's use what we call the power. So g prime of x is equal to, take the 5 times 3x plus 2 and 5 minus 1. But don't forget, we have something in here, okay? We have something here that we didn't take the derivative of. So the derivative of that part on the inside would be 3. This is the derivative of this. Okay? Everyone see that?
No, I'm just understanding now why you did the first one by times 2. I was wondering where that 2 was from. So the derivative is usually the first number on the inside.
Are you referring to this example I'm doing right now?
Yes.
Listen, if I ask you, let's look at this from a different perspective. Example. If I tell you g of x is equal to x to the fifth, what's g prime of x?
X? No. The fifth? 5?
It's 5x to the fourth.
You subtract 1, but then
You always subtract 1 and the power comes to the front. That's where this 5 is coming from. You have to look at those rules in your class notes from section 3.1, 3.2, and 3.3.
Sort of like the logarithm.
Well, it's the power property, yes, but yes, it's certainly similar to the power property of exponential logs, yeah. Yeah. So this power here comes out here always, and you always subtract 1 from it when you rewrite it to power, always. So that's why this now we have subtract 1. And then the chain will be take the derivative of what's in the parentheses. Okay, this is the derivative of inside the parentheses. That's what it is. Okay, so if we simplify, let's simplify this. We will get g prime of x is equal to 15 3x plus 2 raised to the 4th power. Why 15? Because we have a product here. So 5 times 3 becomes 15. Okay? So you can see that this formula, right, can sort of be simplified of what we have here. Okay? Right? Example, find the derivative of y equals the square root of 3x squared minus x plus 1. Okay. So remember, derivative deals with powers, okay? So please rewrite this first using power. Try to see if you can find what is dy dx. Okay, see if you can try it on your own. Take 2 minutes and try this. Let's see what happens. So the hint, write using exponents, because derivative is always subtract 1 from power. So this is y equals 3x squared minus x plus 1 raised to the 1/2 power. Anytime you have derivatives, my suggestion would be to write it using powers. Now, dy dx, the derivative, pay attention, what does this really mean, right? Okay. That means the derivative of the function y, the derivative of the function y with respect to x, meaning the function, this variable here is x. This is the same as if we write y prime or f prime of x. There are different ways to write derivative. Just like how sometimes if I call upon you, I'm going to call on Mangar because she was one of my pros. Sometimes I call her Mangar, sometimes I call her Yo, sometimes I call her Miss. Okay, sometimes I call her Turana, her first name, if I pronounce it right. So the different names for the same thing. dy dx, okay, dy dx, y prime, f prime. They all have the same meaning. Now keep in mind that if this variable here was not x, you wouldn't say dy dx. If this variable here is a p, then this would be dy dp. Okay? And it wouldn't be f prime of x, it will be f prime of p. Okay? So we have y, so you're given y is equal to 3x squared minus x plus 1 raised to the 1/2 power. So the power here is 1/2. So y prime is equal to power first. Always start out with the power. 3x squared minus x plus 1, and we 1/2 minus, since this is a fraction, as I said above here, somewhere, right? Hint, fraction power subtract 1 implies the denominator divided by itself. So what's the denominator of my example for this fraction here? The denominator is 2, so I'm going to subtract 2 over 2. If the denominator here was 5, I would subtract 5 over 5. Okay? Now, we're not finished. We're not finished. Times the chain now. What's the derivative of this thing in here?
3.
Well, the derivative of that would be 2 times 3 x 2 minus 1. I need some room. Okay. Minus the derivative of x is 1. The derivative of any variable is 1. The derivative of p is 1. The derivative of just b is 1. The derivative of a variable, right? And why are we getting 1? Because this is x that is 1 power, isn't it? So this becomes 1x to the 1 minus 1, which is 1x to the 0. And x to the 0 is 1. So 1 times 1 is 1. That's where I'm getting it from. Okay? So if we simplify now, if we simplify all of this, we end up with y prime is equal to 1/2 3x squared minus x plus 1 to the negative 1/2 power times 6x minus 1. Then this 1/2 power here means 1 over that. So this becomes 1/2 3x squared minus x plus 1, everything over this to the 1/2. Actually, let me write that properly. 1 over 3x squared minus x plus 1 to the positive 1/2 times 6x minus 1. And then 1/2 power, this 1/2 power we know means square root. So this becomes 1 over 2, 1, the square root of 3x squared minus x plus 1 times 6x minus 1. Now if you multiply all the numerators, this, and this, then we have 6x minus 1 over 2 times the square root of 3x squared minus x plus 1. So this is y prime. Okay. Final answer would be this here. So it's a lot of algebra or algebraic steps behind it. Okay. A lot of algebra steps. Any questions? Question?
Can that be simplified any further?
You could rationalize the denominator, but we don't care for that right now. Okay. So let's look at another example and then we'll see if we can understand what this is trying to say here with those colorful highlights. Okay. So in the next example, let's try to understand this. Okay. So as I said before, n comes here. Okay. So example, f of x is equal to 3x minus 2 raised, let's make it a little more. X squared to the third power. So what is n? Let's try to figure out this. What is n in this example? What is n?
Isn't it 3?
What is it?
3.
3, yes, I can hardly hear you. So n is 3, right? So this say n, right? So this is my n. And what is u? What is u in my example?
3x minus 2x squared.
Very good. So if you have that, then we can follow this, okay? So f prime, also known as d dx, f prime of x says n, which is 3, times u, right? U is 3x minus 2x squared, n minus 1, so 3 minus 1. Are you guys with me so far?
Yes.
Times u prime. If this is u, what is the derivative of this? Well, the derivative of this, the derivative of 3x is 3, and the derivative of this is 3 minus 4x to the 1 power. Okay? Now we can simplify. Any questions with that?
Professor, what is this rule that we're following?
It's the chain rule, but it's a
Chain.
simplified version of the chain rule, really.
Okay.
This is the way you guys should work all the problems, in my opinion. Anytime you have this scenario, something raised, when I have a function raised to a power. Okay?
Okay.
So can the
So-
function be raised to anything than prime? Anything different than prime? Or
I don't
just
understand.
prime?
I don't understand what you're asking.
F prime, f of x, f of prime x, or something like that.
This here,
Yes.
that's the first derivative. Yes, if you look at the last class notes, we have higher order derivative. It could be f double prime. But f double prime just means you have to take f prime first. Do you work, miss?
Yes, I do.
Okay. Do you want to share with me what you do, if you don't mind?
I am a caregiver,
You're a caregiver. Are you a supervisor or just the regular?
regular.
Okay. Now, at some point, if you're good, which you seem to be responsible, because I know you for a little while now, okay, you may become a supervisor, wouldn't you?
Not in that job. I'm just doing this because I have school.
Okay, but if there was a supervisor position, I'm sure you would have get that position if you apply.
Yes.
And the reason I say that is because what the scenario I'm trying to make, or my point here, is that you first have to go through what is called the dirty work before you get somewhere.
Mhm.
F prime is the dirty work. F double prime, so you've done the dirty work, then you have to get to the next level.
Mm.
F double prime means take the derivative, and once you get the derivative, take the derivative of that derivative. It's like taking two derivatives.
Okay.
Yeah? And I'll show you an example of what I mean. So just hold that thought for a minute. So f of x, let's simplify here, becomes 3x minus 2x squared raised to the second power times 3 minus 4x. Now I can multiply this times this. So this becomes 3 times 3 minus 4x times 3x minus 2x squared to the second power. This can be multiplied out, so it becomes 9 minus 12x. And you probably can simplify this even more if you feel like distributing, but I wouldn't. This is f prime of x. Okay?
Mhm.
So if I ask you what is f double prime of x, then you just take the derivative of this now. Okay? That's what the derivative is. You just take the derivative of the derivative. That's the f double prime of x. Okay? So try this example. I'm going to take a 2-minute break. I'll be right back. So forth. Okay. We also can find derivative of the transcendental functions. So let's look at derivative of transcendental functions with applying the chain rule. And here are a bunch of the simplified version, just like when we looked and we simplify what does it mean. That's when we'll use these here. Okay. So we'll look at maybe a couple of examples, and then that will really be the end of 3.4. Okay. So example, what happens if I tell you find the derivative of y equals, let's say, sine of 5x. Okay. So what is y prime? Well, we'll keep this the same as way, right? You should recall that the derivative if y is equal to sine of x, what is y prime equal to? Anyone?
Sine U,
What is it?
cosine U,
Cosine x. Okay.
Sorry.
All right. So the derivative of sine is cosine x, but because here we have, and that's what this is saying here, the one for sine, okay, you have to take the derivative now of 5x. So the derivative of 5x is 5. Okay, I'm applying this formula here. The u here would have been 5x. So y prime becomes, oops, wait, there's a mistake here, guys. There's a mistake here. Cosine of 5x, I left out the 5, times the derivative of this now, which is 5. Okay. So finally we have y equal 5 cosine of 5x. And this will be y prime. Questions? Any questions? Okay. Let's look at another example. Find f prime of x given f of x is equal to sine cube of 4t. Okay. Please keep in mind that this is the same as if we write f of x is equal to sine 4t, everything cube, right? Same meaning. It's the function cube. So we can say now f prime of x is equal to, n here is 3 times sine of 4t squared. And then the derivative of the inside here, the derivative of sine is cosine 4t times, okay, the derivative of the 4t, which is just 4, the derivative of this. All right, so it gets very complicated, but you have to follow the steps. So f prime of x is equal to 12 sine 4t quantity squared times cosine of 4t. Okay, but please keep in mind that this can also be written as, just as we did before, sine square of 4t times cosine of 4t. And that's our final answer for it. Actually, I keep writing t, supposed to be x, right? So let's change this to the function x. Let's change all the x, f prime of t. Okay, and we can call, say, find f prime of x, and the function is a variable of t. Okay, so this is the way the trigonometrical work. The same thing works also for logarithm function and exponential functions. So this is very important here, right? That x has to be greater than 0. So if f of x is equal to ln of x, then f prime of x, find f prime of x. F prime of x is just 1 over x. Okay. Now, in this example, if I tell you g of x is equal to, let's say, ln of 2x, find g prime of x. Well, g prime of x will be 1 over, not x, it'll be the derivative of 2x, right? The derivative. So this becomes 1 over 2. Actually, this is a 2 here. X times 2, which becomes 1 over x also. Yeah. You can really look at this. You can say, let u equals 2x. And if you want, we can follow this formula here. Right? So it'll be 1 over u. Right? So this here, if you want to redo it, we can say that g prime is equal to 1 over x, okay, times the derivative of u will be 1, okay, or we can just say u prime. Actually, let's take this out, because this is equal to u prime over u, okay. So if u is equal to this, what's the derivative of x? U prime over u will be 1 over x. Okay. So you basically have to just, try these problems and apply the rules that we have. Okay. Yeah, summary. We're finishing up tomorrow's lesson here since we're not going to meet tomorrow, which is chapter 3.4. I'm going to post an extra credit work to see how many of you can work with Lockdown Browser. So if you have a Chromebook, I know it's a problem. For the rest of you, actually, for those of you who have the Chromebook, you will write it out by hand and upload it into Blackboard and send it to me. Yeah. But from my understanding, it's only one person with a Chromebook. Okay. So later today, you have an extra credit on WebAssign. Please get it done.